So this is the last lesson for this unit. There's only 5 lessons, which is nice. And this particular one does not have a practice sheet. You're still going to do the Done with Teacher with this video and submit that, but there is not a practice sheet for this one. It goes straight into the study guide. All right, so let's go ahead and get started with some notes here. This is on angles in similar triangles. Similar triangles have the same shape, but may have different sizes. When two figures are similar, they are proportional. And the ratios of their corresponding sides are equal. Are the two triangles shown at the right similar? And explain. So just looking at them, you can tell, well, okay, they're both triangles. They're both facing the same direction. They don't always have to be facing the same direction, but let's see if they are proportional. So what I'm going to do is I went from 4 to 2. So that was cut in half. Okay, so those two are in the same location, so I can compare the two bases. Now let me see if I can compare this side here. So we have 3 centimeters and 1.5 centimeters. What is half of 3? It's 1.5. So yes, these are similar because they were reduced all at the same amount. What you don't want to see is that the bottom was reduced in half and then the other side was not, because then they're no longer proportional. So we're going to say yes, they were scaled using a proportional scale factor. There's a better way of wording all this, but I didn't want to get too lengthy. Now circle the two triangles that are similar. What do you notice? Well, first of all, they're all triangles, yes, but you can clearly see that one of them has something identical with another, and then the other one does not. So look at them very quickly because you don't really even need to do any math here. All right, if you see it, do you see that this is a 30, 90, 60, and this one's also a 30, 90, 60. So one thing you'll notice is similar triangles, no matter how big or how small they are enlarged or reduced, the angle measures will always be the same. Okay, so this one is similar to this one, and that's because the angle measures stayed the same. Angle criterion. Here we go. An angle criterion means that if two pairs of corresponding angles in a pair of triangles are congruent, then the two triangles are similar. Okay, so let's just go ahead and get into the math. Number 1, are the triangles below similar? Why or why not? All right, well, first thing I notice is they both have an 87-degree angle. Now, if I took 58 and 35 and 87, would it equal to 180? So let's do that. Let's do 87 plus 58 plus 35. Oh, it does equal 180. That means that this one has a missing measure of 35 and this one's missing the measure of 58. So yes, the angle measures are the same. And there you go. It's that easy. Number 2, are the triangles below similar? Why or why not? Okay, well, again, let's see. This one has an 80 and this one has an 80. So basically, if I add the other two and add it to the 80, do I get 180? Let's see. So I'm going to say 60 plus 54 plus 80. Oh, holy cow, I'm way over 180. So there's no way that these two triangles are similar. I could not put a 60 here and a 54 here because it doesn't even equal 180, which is not a triangle. So my answer here is going to be no, the angle measures are not the same. Number 3, Jacqueline constructed triangle ABC, where angle measure for A is 53 and measure B is 112. Ruthie constructed triangle RST, where the measure of S is 112 and the measure of T is 15. Could these two be similar? Well, I noticed that they both have 112. So what I'm going to do is add 53, 15, and 112 together to see if it comes out. So we're going to say 53 plus 15 plus 112. Does that give me 180? So let's check this out. So 53 plus 15 plus 112. Yes, they are. This does equal 180, so we're going to say yes. All right, so on to the back. You are going to tell me if they're similar, explain, and then tell me what is its proportions. So what is it increasing by or so one thing I notice is that they both have a 47 degree. All right, so that tells me if I take this 68 and this 65 and add them up with the 47, does it equal 180? That's the fastest way to check to see if they're similar. So I'm going to say 47 plus 68 plus 65. Okay, great. So this does equal 180, which means this value here is 65 and this value here is 68. So right away, we're going to say yes, and you can say because the angle measures are the same. Now, to determine if it's proportional or not, you need to look at the sides of the same angle measurements, okay? So this is kind of tricky. You have a 47 and a 68 here. So this side here has the 47 and a 68, which you have to look over here. Which side has 47 and 68? That's this one. So those two go together. And then this side here has the 68 and 65, which equals this one. And that's a little question mark, by the way. So what I'm solving for is this right here. Okay, so I'm going to put together the two that are the same. So I went from 15 to 12, and then I have 10 to what? All right, so I'm going to grab my calculator. Proportions are always written kind of like a ratio. So we're going to do 15 divided by 12, and that's going to give me a 1.25 difference. So I'm going to put this in for x. So I'm going to say 10 divided by 1.25. And the reason I'm dividing is because this triangle is larger than its new image. All right, and I can tell because this went from a 15 to a 12. So it's obviously been reduced. So by reducing means we're going to divide. So we're going to do 10 divided by 1.25, and I get 8. So therefore, my x equals 8. All right, so I'm going to let you guys try 5, 6, and 7. And again, you do not need to do the summary.